Hello, it's 4:30 and we're still putting 225 watts into the water heater, 3.6 amps and 61 volts. Let's go down here, look at temperature. It's 118.7. This is what the waveform looks like. This is the FET turning on. Low is when it's being powered. Now, one of the interesting things about this is that yesterday I showed you the red LED was on. That indicated the upper element was on. So we're running with half the elements, and so it's twice the resistance. And I'm going to switch in the second element, and we can see it switched in. The current didn't change, and here it is. This is with 2 elements, so this is like 6 ohms, and that's with 12 ohms. Now the upper waveform is the AC portion of the top of the 60 volts, and that's only about 2 volts. This shows the capacitor discharging. This is it charging up, discharging. So anyways, I was going to show you, my intention was to show you like a simple video of 2 wires going in the board, 2 wires going out, but I can't ever do that. So over on this side I have a loop, and I'll put the current meter on it. Okay, there we go. And so it's 3.75, and this is the output, 3.64, 3.62. So you can see that the currents are the same, but this is a steady state current. This is the input, and this white loop here is the output, and that's the average. So you're taking the pulse times the voltage on the input, and the output is exactly the same. So you're just putting a pulse going out. You're seeing this light flashing here. Sometimes it'll get really flashing. I don't see it flashing if I look at it normally. That's effect of the strobe of the camera. But what you'll get is this has a hard reset to it, and so when it goes below a certain voltage, it absolutely turns off for a minimum amount of time before it's allowed to turn back on again, and that prevents any oscillations. Sampling voltage is a lot like a machine gun. You can point a machine gun, the first shot is good, but the rest of the shots, you don't know where they're going to go. So it's a way of preventing oscillations, just having this hard reset time until things stabilize. So up here are the connectors for the board. These are the 2 FETs. You can screw in a new FET. It's if something goes wrong, lightning hits. The Tech Luck, had some issues with the power supply, and it was real prone to damage from, a lightning strike or some kind of pulse. And when you damage the power supply, the main dropping transistor, it wiped out everything. I had one of the boards in. The only thing that wasn't damaged was the protect diode. Didn't do its job though. I use this high dance A-torch power meter. I kind of like them because you can do graphing, but you have to have a phone sitting by it all the time with the Bluetooth. This is a great use for, if you have an old phone or an old tablet you don't use anymore, just download the program through Wi-Fi. Now see, the refrigerator or something is turned on. The array has dropped to 27 volts, and we've essentially, turned off the heating element. So yeah, good thing that happened. Just shows you the thing how it works, and it'll recover at some point. I've noticed this with all my charge controllers. I have heavily shaded panels, and I have a lot of them in parallel. That's why I go 60 volts. Oh, see, now it just came back. But the charge controllers get really confused. If they hit a heavy load, they'll drop down to a lower voltage, and they seem to sample some hump down there and say like, ooh, this is where I'm supposed to track. So I got that red light on there. We'll turn that off. But like I said, 119.6. We're just clocking away, and you don't see any nasty spikes or anything. You know, there's no oscillations. This is clean. Someone else did a board, and you know, they thought they were going to save a few parts from what I was doing, and it oscillates like crazy. You know, people are saying that oscillations go from like 400 kilohertz up to a megahertz. And that's that problem with you know, sampling voltage just after you've drawn a lot of current. There's oscillations, there's spikes, noise on the line it picks up, and it just goes crazy. It turns on off, on off, on off, and that just heats up your FET. You know, these are cool to the touch. You know, something like this where you have a cabinet and just mount them on there. FETs themselves, you know, if they heat up just a little bit, their on resistance changes. And so, like, why buy a FET just to heat it up? You know, FETs are cheap. Use 2 instead of 1, and then you get really the true on resistance of the FET. Otherwise, you know, the FET resistance can double, and when it doubles, the heat they produce increases by 4 times. So you don't want that. This whole thing stays really cool. It's a nice little unit, and like I said, you know, 3.17, 3.41, yeah, 2.25. You know, input matches the output, you know, if you believe these meters, but that's it. So this is the, like I said, that's the A-Torch DT310. They have a little nasty problem. Around 17 volts they turn on, but with an array that's warming up slowly in the sun at about 17 volts, this unit will flash on and off, turns on, off, on, off, on, off. And I have one of these which is locked up. I finally got the factory to give me the recalibration procedure. I'm going to have to go through that. But I use a little relay here, and basically it, you know, when you get above 17 volts, it'll turn on. I think this one, the way I have it set up is it turns on about 40, and it turns off about 20 volts. And it's more than enough. But, you know, that keeps me from having a unit that needs to have calibration. I've had these, I've been using these for a while, and I really like them, you know, except if they just clean up some of these problems. The one I have at home, you know, I'd be upstairs and, you know, I check it through Bluetooth, and it reads 0, 0, you know, 0 amps, 0 volts. And I go down there and it's like, you know, clocking away, but the Wi-Fi didn't work because it got reset wrong. And other times I'll read, I'll go down and read it, and it'll be, you know, 0, 0 again, or 0 amps or whatever. And I know it's producing a lot of current, and I have to remove power, turn it back on again, and then it works. So just to avoid that and have any confusion, you know, put a relay in. It'll save you some hassle. But hey, the system's working, and like I say, we're back up to temperature. 2 days ago I did 2 loads of laundry. Yesterday I did 1 load, and we're back up. The temperature up, you know, 120 at the top, and the bottom is warm. I've put in about 2 kilowatts today, and this is, you know, this is only the laundry system. You know, the temperature isn't critical. This is just handling everything that's not used by the rest of the house. The other house has water heaters, and you know, they've shut off, and power to be wasted, so we send it out here. And this comes out over like 125 feet of number 12 wire. So you know, there's at least a voltage loss on it. Oh, see, we're down to 32 again. I used to have a relay on the charge controller that when it dropped below 40 volts, it would turn it off, it would disconnect the panels and connect them back up again, and then everything would be back to normal. Power would be 4 times what it was. See, we're up to 61 again. I hate MPPT controllers. Of course, maybe if I paid $600 for one, they'd work better. So that's it. Thanks for watching.